This is Algebra Lesson 8.1, Exponents. So exponents are a way to represent repeated multiplication. And what that means is if I was going to take something like 5 and multiply it by another 5, and another 5, and another 5, and so on, I could use an exponent to represent the number of times that I was going to multiply that number. So a times a times a times dot dot dot, where n refers to the number of times that we're going to be repeating that base. A couple of formulas then. If I have a to the negative n, that's kind of like dividing instead of multiplying. So it would be 1 over a to the n. I would be dividing it by that many times. And then a negative in the denominator would move it to the numerator. You don't really have to write it over the invisible 1 anymore, but it kind of flips that fraction over. And if I have 0 of something, I don't have nothing, I still have the invisible 1. So we can try to take some of these exponent ideas and try to represent some numbers a little differently. The first example says to write the expression in expanded form. So 8 to the power of 5 would be 8 times 8 times 8 times 8 times 8. And that's all it's asking me to do, is to write it in expanded form. I don't need to get an answer. We're just showing what 8 to the 5 is really representing. 4 to the negative 3 would be 1 over 4 times 4 times 4. So I would have 3 4s in the denominator because the negative exponent is telling me to technically divide by 4 3 times. And finally, x to the 5th would be 1, 2, 3, 4, 5 x's. Right, an exponent form is just the reverse. We're going to take however many we have and use that as the exponent. So I have a bunch of 3's. How many 3's? 1, 2, 3, 4, 5, 6, 7. So I would have 3 to the power of 7. I have a bunch of 2's. How many 2's? I have 5 2's, so it would be 2 to the power of 5. Now I have a bunch of a's, so it's going to be a to the power of 1, 2, 3, 4, 5, 6, 7, 8. Letter C says find the value of the expression. Here we're actually going to calculate a numerical answer. So I would do 2 times 2 times 2 times 2 times 2. And you do have 2 options. We could go 2 times 2 times 2 times 2 times 2, but that seems to take a bit of time. It seems a little bit silly. What would be easier is 2 to the power of 5, but it gives us the same answer. So making sure on your calculator you know how to do the power button. On this calculator and most of the Texas Instrument brand calculators, it's a caret. It looks like a little arrow pointing up. If you are on some cell phone calculators or some other branded calculators, let me see if I can pull this one up. Sometimes you'll see an X to the Y button like we have right here. That would be the power button on this calculator and some cell phone calculators. So if you're not sure, let me know and I'll try to help you figure out how to utilize your calculator. But this one here would be 32. 7 to the power of 4. Again, I have a couple options. I can go 7 times 7 times 7 times 7. And if your calculator doesn't have a power button, that's your only option. Or I can go 7 to the power of 4, and I get the same answer, 2,401. Okay, negative 3 times negative 3 times negative 3 times negative 3. Instead of actually typing that out, I'm going to go negative 3 to the power of 4. If I had typed it out, negative 3 times negative 3 times negative 3 times negative 3 should give me the same answer. And I want to point out that I used parentheses on my negative before I raised it to the power of 4. And I did that because this specific calculator will give me the wrong answer if I just go negative 3 to the power of 4. Because it's actually doing 3 to the power of 4 and giving that answer as a negative. But I do want a positive number for this answer. 6 to the power of negative 2 is the same as 1 over 6 to the power of 2. 6 to the power of 2 is 6 times 6, which I know is 36. You could still use your calculator if you needed to. 6 squared, or 6 times 6 to get that same answer. Letter E, I would have 1 over 5 to the power of 2. That's going to be 1 over 25. 5 times 5 is 25. 1 over 5 squared, well, that's just the same exact answer, isn't it? 1 over 25. And I put this here for a reason so that we can see with that negative power what that should look like compared to when it starts in the denominator. And the last one is g to the power, 7. 7 to the power of 0. So that would be 7 times itself 0 times. That doesn't really make sense. But we can do 7 to the power of 0. And hopefully that makes a little more sense. It's kind of like saying if we have 0 sevens, we're still going to have the invisible 1 that we talk about as our coefficients. So it's 1. And this would be 3 over 2 to the 0, which is technically 3 over 1. And we don't write that invisible 1. That's why we would just write 3. That is it for the notes. Good luck on the exercises, and please let me know if you have any questions.